We don't want to upload it in the background yet.
Did you say our group's meeting?
All right, so I've got recording started in both places, and we have the application sharing on, so you're seeing the desktop, which is perfect. That's what I want you to be able to see. I was going to spend just a couple of minutes kind of talking about the where we're at, where we're headed, because we've gotten a little bit behind on the projects with a couple of the teams, and so we haven't maybe turned things at the same time frame that I thought we might. So what we've got left is we have 3 15-point homework assignments, and I'm going to finish by tomorrow afternoon. I'll have the Chapter 6 homework problems posted out there and some really easy ones from tonight. And I'm going to take that approach because I want you fundamentally to get these relationships that we're talking about. And they'll be on the discussion board. So they'll be the kind where you go out, you do them, and then as soon as you post, you can see your responses, and then you can turn around and post your corrections. And as long as you post your corrections, the intent is that you're learning those relationships, and so you'll do fine in terms of the score on those. So we'll get the Chapter 6 finished up and Chapter 7 homework problems out there. Okay? And then after we meet on December 1st, our last thing to do in the class, because we're not going to do a final in here, the project is kind of your final thing, is then there'll be a 15-point, and they'll be a little bit harder than the ones that you'll do for this week, but you should already have some of the relationships down, and so you'll be able to do those. Because we won't meet next week unless your project isn't done, and then you'll need to come in and meet with me and go over your project and make sure that we understand where we need to go from there. So that's kind of where I'm at with it is I think I'll have one that probably will have her project done, and I'll probably need to meet with the other 3 just to make sure that we're on target.
I know we sent ours back in, me and Lauren, and we worked on it Wednesday, so I think we're waiting on maybe you.
Nope, I sent it back to Lauren on Sunday.
Okay, good deal.
I saw her in the hallway, and she told me that she was not going to get to it until Sunday night.
Okay.
And I said, well, if you're not going to get to it till Sunday night, I had a paper I was finishing up, and I finished it Saturday night at about 6, and I was like, wow.
Right.
And then I was home on Sunday and went, I need to get back to Lauren. So,
what kind of paper does Dr. Betts write?
This is a paper that comes from data that I collected from 500 manufacturing plants, and it's about stakeholder pressures, and if you think about the different types of stakeholders that exist, what we know from research is we have external stakeholder pressures, we have internal, which are going to be employees, and then we have governmental, and then we have others like media kind of stuff. And so you look at those 4 different categories of stakeholder pressures, and we look at it and we say, given those categories of stakeholder pressures and environmental strategies that manufacturing plants implement, what's the relationship between those? How much do these stakeholders influence the decision in terms of what environmental strategies companies?
They used to do that because that's just what you do because you're a doctor or doctor?
Yeah, it is. And here's the challenge. The research part of it keeps you engaged in what's going on in the academic community, but that research in and of itself is, if I tried to take it by itself to a manufacturing plant, and what they're going to tell me is it's so narrow and so specific. You've taken all the assumptions out of it. It's hard for it to apply. And so there's kind of 2 types of research that you do. So one is I have to do a certain type to be academically qualified. That's this type, and it's very technical and very detail oriented. And then there's another kind that says, as an example, Dr. North is planning on working with I think they're in West Virginia, but a school district on school bus routing problems, right? And so then that's more applicable type of research. And so my goal is to balance it. And you have to do the academically qualified to be able to teach.
Yeah. I was going to ask you if that was like a Murray State mandate. Now, do you have to just publish a paper a year, or is a paper ever?
It's roughly that. Okay. So, and I have some flexibility. If I publish that academic one, then the next year I can probably get away with the practical one.
Okay, you just got to constantly be.
But there's got to be something in the pipeline. And because I'm on tenure track, it's incredibly important right now because if I don't have enough when I go up for tenure, then that's an issue.
And once you get tenured, like I don't have it.
No, because then I'll be, I hope to go from assistant to associate. And then in order to go from associate to full, you have to do the same thing again. So you kind of have to keep that pipeline going. So, but again, I can see us moving, like I shouldn't say, but we've had a company that has asked us about maybe some project work that we might be able to do for them, and I'm very interested in that kind of a thing. But the challenge is I have to get my academic research done first, because if I don't get that done, then I don't have a job. And so it's like I'm finishing that and then going on to the more, my passion is probably more the practical approach. So,
Oh, yeah.
because I think that you're making a difference in the community then when you do that. So, okay, so I did get back to Lauren. Yeah, I did get back to Lauren, and so she had that information, and I haven't looked to see if she's uploaded anything or not.
We talked more, and so I'll talk to her again after class.
Okay, and so to just rehash where we're at, Chapter 6 for 15 points should be up by the end of today, tomorrow night. Chapter 7, the beginning, will be another 15 points that'll be up on the discussion board. Okay, and then the final Chapter 7, 15 points, which will be more of the apply kind of multiple things together to solve those problems, a little bit more complex, will be up then after that December 1st meeting. And if I happen to get those done ahead of time, I might post them. I know I've got one or two of my online students that are trying to move ahead and move through, so I'll get those posted as soon as I can, that last set. We have an exam that was originally due to be done by tonight, and because we had the projects that we're still working on, I've decided that we're still going to do the exam, but it's open book, open note, and there's no time. So you should be able to work your way through it. And so it's almost like a homework assignment. The key for me is that you do it yourself, that you do not get help from anyone else. If you get stuck, you come see me and we walk through how to do it, because I want to make sure that you've got that understanding of how to do it. So don't be afraid if you get stuck. It's not that you can't ask questions. And what I might do is show you on another problem and let you finish your exam, but that will be the approach. And the other thing is you can go back and watch, we've got all the lectures recorded, so you can go out to the YouTube links that are on the lectures, and you can fast forward to a particular spot that might be helpful to you as well. Okay, so that exam also will be posted by the end of tomorrow. What I've decided, again, I feel like I'm being fairly lenient here, but I don't have a real reason not to be, is that'll be due by December 1st. I'm just not going to make it be something. I think it's more important that you take your time and get through the problems first. So do those mini 15-pointers for Chapter 6 and the beginning of this Chapter 7. Do them first, and then go on to the exam.
And what's the test over?
It's over 6, 8, and just what we're doing on Chapter 7 tonight. So that should, and so that's a change from what was in the syllabus, because I didn't have Chapter 7 on there before, but we're just going to go over some pretty straightforward stuff tonight, and so that'll be on there. Again, open book, open note, ask questions, so I'm not feeling too bad about doing it that way. All right. And then your last round of your the goal questions should be done by the 24th, by next Monday. So if you get those turned in, I'll try to kind of keep up with the grading in terms of getting, as you submit, I'll try to go back on a regular basis and grade as we go. The key thing, you've kind of got to balance, you've got to get this project done. And so, my hope was kind of be that we'd be done with the project at this point and just on to the kind of easy end of the semester. Most of you, I think, are getting through the toughest part of the project. So when you get through with this Chapter 3, Chapter 4 section, I think those are the tougher parts of the project. And because you've got the data, then the 5 and the 8 section, they flow better. So, okay. Any questions about where we're at or where we're headed? For online students, there has been a link posted, or not posted, I'm sorry, but you've been sent an email to do a course evaluation. I would really appreciate it if you would do that. And I will probably send an email out to each of you asking you to do that individually as well. For on campus, when we meet here on December 1st, we'll do them here. Probably what I'll do is, Amber, I probably will ask you to just run the whole, here, do them, and then you can seal them up and give them back to me in a sealed envelope, and I'll turn them in the following morning.
And then December 1st, our last class then.
Yeah, December 1st is our last class in here. So, and we won't, what we'll be doing at that point is finalizing your presentations to your clients, is kind of where project-wise you'll be at, right? So we still have some work to do, but there won't be a comprehensive final, and it's just kind of about tying up any loose ends we have at that point. So I'm sorry I've got my outdoor scarf on, but it is like freezing upstairs in my office, and I'm still in the process of warming up. What's that?
It's okay.
So we don't come on finals week?
No, we don't. Well, the only thing that you may have to do is if you're presenting to your client on finals week, we'll just have to make the time. So that'll depend on where you get to with your projects and when your clients are available to meet with you. Okay? All right.
I just have another question.
Sure.
Do the online students present with us, or is it just whoever's in class?
It'll just be you if you're on campus.
Okay, I wanted to make sure.
Yeah, they could help maybe do the presentation in terms of putting it together, the PowerPoint, put that together.
Okay.
But in terms of who's going to do the presentation, if we did it in here, we might be able to get them to participate. That's not necessarily a huge requirement for me, because what I have found is it is very difficult to get for students, especially one that's online, a client and myself, to get schedules to match up. So we just need to find a time that works for the majority of us and go forward with that. That PowerPoint that you all put together, though, that'll be, we'll be talking about that in terms of the story that you're telling. So, okay. All right. So I went through and kind of redid these PowerPoint files for this class because, let me switch here. I know, I stumble over this every time. Swap presenter view and slide view. There we go. Okay, so this managing business process flows, this is really a throwback to 343. So the main difference is that they use just slightly different variables in terms of the letters. The meaning of the variables is the same. But I don't think it's a bad thing because we've spent a lot of this class talking about service, and we're kind of getting back into inventory, actual physical inventory and quantities to order and that kind of a thing. So basically, we're going to, here's the online. Please go to your email and complete the instructor evaluation for this course. On campus students, we're going to complete evals on December 1st. I wanted to make sure I didn't forget that. So why having the right amount of inventory is so important? I've got some examples here from Apple's iPhone. Broke sales records when it sold 1.7 million units on the release day. Yet people were lining up to buy the gadget a week later. It's estimated that Apple could have sold up to 2 or 2.5 million more of the iPhones if they could have produced more units. Okay. During 2007, Nintendo's game system Wii was hard to get due to supply shortages. Analysts estimate that the company was leaving close to 1.3 billion on the table in unmet demand. Okay. That comes from TechSpot. Mumbai's real estate is said to be hot property. I'm sure this is dated 2011. However, in the last quarter, sales have dipped so low that builders are getting worried. At the current pace of consumption, it will take 2 years and 4 months to exhaust the current stock. Okay, this is alarming because a healthy market is supposed to have only an 8-month inventory pileup in terms of real estate. And so, it's not just product, I mean, I don't know that I always think of real estate as inventory, but the same concepts that we talk about with service and with this with a direct manufacturing example apply to the real estate market as well. Okay, here's if you have, so those were examples. The first two were examples, or the first three were examples when we didn't have enough. This Blue Fly example, an inventory write-off widened the fourth quarter losses at Blue Fly despite a substantial increase in revenues at the online fashion retailer. Fourth quarter revenues were up 10%, but the inventory write-off knocked back gross profit by 7%. So, having too much on hand can be a problem too if you think about having to slash prices to get it sold. And then the last example that we've got in December, so this would be 2011 again, a report released by the Canadian Pharmacists Association. Nearly 90% of pharmacists across the country said shortages have greatly increased in the past year. Antibiotics, anti-nausea, and heart drugs are among the top medications that pharmacists say are in the shortest supply. People who can't get access to their primary drug of choice may be forced to go without or take alternatives, right? Pretty serious. If left unabated, the situation could cause someone with depression to commit suicide or lead other patients to experience serious health problems because they couldn't get the drugs they needed. So, inventory matters in a lot of different ways. Some of the things that I'm hearing about today's environment are that the ports are getting incredibly backed up. And have you heard that as well? And so it's hard to get some things in that we're importing from China and other places because I wish I had the article with me, but the statistics are pretty astounding in terms of its days and weeks in terms of how they're starting to stack up. And then if you think about supply at Christmas time, which is a huge market, so let's say you've ordered it and you don't get it when you're supposed to, now you get it a week before Christmas instead of a month before Christmas. What do you have to do? You have to put it on sale, right, in order to get it to move as quick as you want it to move. So you're going to, what retailers are going to see is they're going to start seeing lost opportunity for sure. What have you heard?
It was on the news on that stock channel.
Okay.
And they had mentioned and talked about how it's going to affect something with the holidays. And
yeah.
Like some, stuff that have been like anticipating this quarter
to really make it a good deal for them. And now some companies are going to struggle because we have. And then I think on top of that, I heard that 2 weeks ago, and then this last week I heard that there's also a risk of a strike at the ports. So you can imagine how that would then further complicate an already tough situation.
First it's strike, I was thinking terrorism, and then I was like, okay, she's talking about workers strike.
Right. And if you think about when it makes sense for workers to strike, they are the most powerful when there's already this buildup and it's already holiday season. There's going to be a ton of pressure for people to step in and say, we need to resolve this, right?
There was a stat on it that like companies within their first 5 years that depend on this, it was like 30-something, or maybe even 40-something, will go out of business this next year because
they don't have the supplies that they need when they need them. Yeah.
Certain industries too. I can't remember which ones.
Mm-hmm. Well, if I find that article or that piece, I'll go back and post it. So, the question is it all in the forecast? If we get the forecast right, does that make it perfect? Well, it doesn't make it perfect, but it certainly helps, right? And if you can predict the variability that you're going to have, then that's going to help as well. And so what we know about forecasts are that they depend on historical data and market intelligence. Because if you just had historical data, knowing about what was going on in the ports, you wouldn't know that if you were only looking at historical data. So you have to look at basically what's happened and then what you think is going to happen. Okay? Here's some things that we know about forecasts. They're always wrong, right? There's almost no way to get them 100% accurate. I used to, back when the boys were younger, I'd bring into class a dart gun and a little target for people to shoot at. And I would say, Brady, I'm going to stand right here, and I'm going to give you the gun, and I'm going to let you shoot at it. And then I'd hand it to Harley, and I'd say, now you shoot at it. Now who's going to be more accurate, you or Harley?
I would think me closer, but...
Right, you're closer. So forecasts work in that same way. The closer you are to the time frame that you're going to do, the more accurate you're likely to be with your forecasts. And the farther away you get from when you're trying to forecast, the less likely you're going to get. Okay. The other thing is that aggregate forecasts tend to be more accurate than very specific. So when I'm at Pella Windows and I'm forecasting for the Story City plant and I say they're going to do maybe 500,000, let me think about that for a second. I was going to try to get somewhere in the ballpark. I can't remember exactly how many they used to do. If you did 2,000 units a day times 250 days in a year, what does that give us?
250 days, 2,000. I think it's 500,000. Or is it 5 million?
2,000 units a day times 250 business days.
2,000 times 250. 500,000.
Okay, so roughly 500,000 units in a year. Okay, so that was a shift. So make it a million. So a million units in a shift, or a million units in a year. So if I'm forecasting total units and I say it's going to be a million units next year, and then I say, but how many of a particular size, of a particular glass type, and of a particular finish color, how many of those, I'm much more likely to be accurate at a million than I am when I drive down into the very specific part of it. So aggregate forecasts tend to be more accurate. Okay? All right. And a good forecast has at least two numbers. We talk about forecast error and standard deviation because we're trying to look at, with forecast error, we're saying over the long run, right, how close are we to being accurate? And if I'm way high or way low from 1 week to the next, maybe that doesn't matter as much as if in the long run I'm accurate. However, I'm probably also interested in the short run, from one time period to the next, how big is my gap? How far am I missing my forecast, right? Because I can be high or low, but that gap can be high. The highs and lows can average out over time, but from time period to time period, that can really make an issue if I really have a miss there. So that's why we have those two different measures for forecast error. Okay, so in example 7.1 in our book, we talk about reorder point. Okay, and safety inventory is the difference between the quantity that we order as opposed to what the lead time is. So it's just how much buffer we're carrying. That's our safety inventory. Okay. For example, if I know that average lead time demand has been 20 units, so lead time demand says if it's going to be 2 days before I get my order and it's 10 units per day on average on my demand, my lead time demand is going to be 20 units. You guys following that math? Okay, that comes right from 343. But I reorder 24 units, but I reorder at 24 units, right? Rather than the 20 that my actual lead time demand is, then my safety inventory is 4. Okay, so my difference between safety inventory is my reorder point less my lead time demand. That's one way to look at safety inventory. Okay, and we're going to have a couple of different equations for that. So part of when you do these little homework assignments is going to be recognizing what information you have and how you can calculate inventory safety stock with that. Okay, we can utilize statistics to determine the amount of safety inventory we need to meet a specific service level. Okay, so if we agree from the slide before last that forecasts are usually wrong, then we have some things to consider. Actual requirements will fall below units, resulting in excess inventory, right? And then we have costs because we have to hold on to that excess inventory. Or actual requirements will exceed the forecast, resulting in stockouts. And so then we have the cost of lost sales and the cost of lost goodwill, so the loss of future sales. So as an example, Brady, if you have people coming into the dealership and they're looking for a particular car and you don't have it, do they
go buy it somewhere else?
They go buy it someplace else, right? And so that's that cost of a lost sale. And you might have lost goodwill because they think, man, they never have what I want. I'm not coming back here again, right? And so there's that kind of combination that you've got there. So when we have stockouts, we can deal with them in a couple of ways. One of them is we can backlog orders. We can say, that's all right, well, we'll order it for you and I can get it in, right? And that's where customers are willing to wait and have their needs satisfied at a later date. Or you can keep some kind of safety inventory or safety stock to cushion against that variability. Yes?
When we adopted all those accounting methods and stuff back in the 70s or whenever, did they not have, like the Japanese or whatever, did they have a better way of the forecasting?
I don't know that I would say that they have a better way of forecasting.
If it's usually wrong, I just didn't know why it wasn't.
Well, it's because when you forecast, you're making a prediction, and so it's always wrong. I mean, so even the Japanese, their forecasts are always wrong. The question is, how far wrong are you, and are you trying to figure out how to get better, okay? And what factors influence that? So that's not that the U.S. is worse than any other country. Yeah. It's just in general, forecasts are wrong, and one of the drawbacks is
number, I guess.
What's that?
Because you're giving an exact number or a
you're trying to predict an exact number, and really who can really predict the future. And that's one of the reasons that I try to teach that is because it's very painful to be in a supply chain manager's position and have a plant manager who doesn't get that, right? Who thinks that forecast should be 100% accurate, and therefore everything should always flow smoothly because they're accurate, and if you would just order to what we forecasted, it would be no problem, right? There's usually an education curve that goes on there where you say, well, right, here's what we forecasted, here's what actually happened, and that didn't work out, right? But here's what we learned from it. That's always the rest of the conversation, and here's how we're going to try to avoid that in the future. So, again, it's just forecasts are, by their very nature, they're just not accurate. And so our goal is to try to take variability out. That's what we do with process management, where we try to take variability out of the system and then figure out what other things influence it. So you want to have somebody like, in this example, we're talking about the porch. You want to have somebody who knows that stuff that you're having those conversations with, right? If you isolate yourself and you don't know these things, you can't adjust or make the right predictions. Okay. So we've agreed. Forecasts are usually wrong. We have a couple of options. We can either be overstocked or understocked. Okay. We have some different service level measures that we use. Okay, and these are going to be the kinds of problems that you're going to see from this part of the chapter. They're going to be really straightforward in terms of, let's just make sure that we understand how to calculate a cycle service level and a fill rate. Okay, and so the cycle service level is that probability that there's no stock out within a particular time interval. The fill rate is just the fraction of total demand satisfied from inventory on hand. Okay, so our example 7.2, if we have 100 time intervals and stockouts occur in 20 of them, then our cycle service level is 80 out of 100 or 80%, right? So it's the number of times that we can fill an order divided by the actual number of times that we attempted to fill an order. Fill rate measures the extent of the stockout in terms of the number of units we were short. Okay, so fill rate is our expected sales divided by our expected demand. Okay, so in this example, during our 100 intervals, our cumulative demand was 15,000 units, and the total number of units short during the 20 shortages was 1,500 units. So the fill rate is going to be 1 minus 1,500 divided by 15,000, which is the 90%. Okay, so I'll probably give you just a couple of real simple problems with cycle service level and fill rate. So this is going to be a good slide to refer back to. Okay. Coming back from chapter 6, our two key inventory questions are how much should I order and when should I order? And in chapter 6, we took a very straightforward approach and we assumed that we didn't have variability. What we do in chapter 7 is where we're bringing in the variability. We're saying we recognize that my demand does not come in exactly the same amount every day. I've got some kind of variability. We recognize that the lead time from the supplier is not perfect, right? I've got some lead time in that, or some variability in that. So the two questions we ask are, how much should I order? And the answer is dependent on the trade-off between the fixed cost of placing the order and the variable cost of holding inventories. Okay? That should, verbally, that's what we're describing with that is the economic order quantity. Right? Because at the economic order quantity, we're saying that we're setting the ordering costs equal to the carrying costs. Okay? And so the ordering costs are the fixed costs, and the carrying costs are the variable costs. And we're kind of setting those equal to each other to figure out where the optimal place to order is. Okay, and our formula for that, you're going to need it for this, and when you go back and do that those chapter 6 problems, is the square root of 2 times your setup costs times your annual demand divided by, that's going to be that capital H is going to be your unit cost times your inventory carrying cost, right? So, and those are both, all that's back in that chapter 6 if you need to do a quick review on that. And then chapter 6 again, once I reach a certain level of inventory, that should trigger a reorder. Well, my reorder point is the lead time times my throughput. Again, very straightforward. If I use 10 units a day and life is perfect and it takes 2 days for it to arrive, my reorder point is 20, right? That's not hard to figure at all. That's just common sense. Sometimes when we look at the formulas, we think they're harder than what they are. They're not. They're just trying to restate what we would do common sense-wise if we were looking at that particular problem. Okay? So in Chapter 7, we extend the EOQ formula from Chapter 6 into the continuous review reorder point policy, which now includes uncertainty in both demand and replenishment lead time. So our focus is going to be on determining the service level provided by a given amount of safety inventory. Okay? So the amount of safety inventory needed to provide a given level of service. So we have some revisions to some of the variables that we use. This is not a huge deal, but if you're reviewing the chapter, you might find it helpful to remember that the bold represents the variable that we're saying is uncertain. The italicized variable represents the average of that particular variable. Because we can talk about the same thing. The bold X means the uncertainty about that, and the italicized X is the average of what we've seen in that. And then the subscript sigma represents the standard deviation of that particular variable, right? So we can have a subscript sigma that's sigma/LTD, which is the variation, the standard deviation of the lead time of demand. We can have the standard deviation of lead time, and we can have, so we've got that standard deviation can come in many different formats as we work through the chapter here. So here's just some basic formulas I want to kind of review before we go farther. All right, our inventory consists of 2 components. We have what we call our cycle inventory and our safety inventory. Our cycle inventory is if I order 1,000 units from the supplier, right, and life is perfect and I use at a steady rate, my average inventory is going to be half of what I order, and that's my cycle inventory. So my I cycle inventory, or I subcycle, is that Q divided by 2. All right? That's something to kind of try to get back in your head. If we use at a perfect rate and I order 1,000 units, my average inventory is going to be 500, or Q divided by 2. My safety stock inventory is the other component. And if you think about how we used to draw that, the sawtooth diagram. Do you kind of remember that? Okay. When we draw the sawtooth diagram, I was going to think if I could get a pen up here. Let me see. Pointer options. Pen. Look at that. Okay. So here's before, right? We use, that's supposed to be a perfectly straight line. Just bear with me and assume it is. All right. So there's our sawtooth diagram. All right. And there's where we assume no variability. So if we order Q, there's Q, and we get our average inventory is then Q divided by 2. Okay? And that's our cycle inventory. But because this doesn't always look like this, sometimes it looks like, that didn't really do what I wanted to do. Ink color. I want pen, and I want ink color. Sometimes it looks like this, right? That's what we're talking about in this chapter. So what happens is we put in safety stock to account for that variability. And that safety stock is that buffer that we put in here at the bottom. So when we add that buffer in, our inventory now consists of our cycle stock, right, this part, plus whatever we have in safety stock. And so that's how you know what your total inventory is on average. All right? All right. So if we're looking for how do we calculate service levels, we have several ways we can do it. We can manually calculate it, or we can use Excel if we know what we need to put in Excel. Excel is the easier of the two if you understand how the formulas work in Excel. But a service level is measured by the probability or the proportion of time that the actual lead time demand will not exceed the reorder point and the corresponding service level. Okay? So if we assume that our lead time of demand is normally distributed, we can do a lot of things with statistics. Okay? And so then what we know is that our safety stock, we can calculate how much safety stock we need to meet a given service level, because if it's normally distributed, let me draw real quick again. And I'll do it in black. I think red makes me feel like there's something wrong. Okay? So here's my normal distribution. Right? Right? And here's the mean. So just as a reminder, if my service level was 50%, that would be right at the mean, right? And so if my service level, if I ordered exactly the average of what people demanded, I would meet service 50% of the time. Okay? And so if I want to improve that, then I need to have safety stock that's above and beyond that mean. Okay? And so I have to determine what we call that Z-score to tell me how many standard deviations away from the mean I need to be to meet a particular service level, right? And so what we say is then that our safety stock is equal to the Z-score of whatever our service level we want times the standard deviation of that lead time during demand. Okay? So in Excel, I can use the formula, this norm distribution, okay? And I can put in what the reorder point is, I can put in what the average lead time during demand is, and I can put in the standard deviation of the lead time during demand, comma true, and it's going to return what that service level actually is. Okay? That's the easy way to do it. All right? All right. That's what I was afraid of. I have to get rid of the pen in order to move on. Arrow options, automatic. Okay. So example 7.3 says that our average lead time during demand is 20,000 units. Our standard deviation of lead time during demand is 5,000 units. Currently orders 14-day supply. I've summarized this. If you want to read the whole word problem, it's there for you. Currently orders 14-day supply each time the inventory levels drops to 24,000. Okay, what does 24,000 represent then? If they order every time they hit 24,000,
Reorder point?
that's the reorder point, right? And then the other thing that we can get to is that we can tell that if I order a 14-day supply and I order and 28,000 is my units, my throughput per day is what?
28,000 divided by 14?
Yep.
Just 2,000.
2,000 units a day. So it's, again, that 28,000, actually, this is a continuation of an example from Chapter 6. So I think you'd have to go back and look for that. But, again, that's the type of information you're going to be given, not in this first time out, but in your next set of problems. I won't spell everything out for you next time. For the problems for tonight, I'll be pretty straightforward with where that stuff comes from. Okay, so how do we determine service level in terms of the proportion of order cycles over which the warehouse will have stock to meet customer demand? And what are the average total inventory and average flow time? Okay, well, here's my formula, right? I use normal distribution, reorder point, lead time during demand, standard deviation of lead time during demand, and true. Okay, so I need to identify what the reorder point is. We did that. It's 24,000 units. My lead time during demand is given to me in the problem. Okay, it's 20,000 units, and my standard deviation of lead time during demand is given to me as well at 5,000 units. So I plug that into Excel, and it tells me that my service level is 0.7881, meaning that 78.1% of the time I will be able to meet customer service with that. Okay. The next part of the question says, how do I know what my total average inventory is? Okay. Well, remember we said it's our cycle inventory plus our safety stock inventory. Okay. And I know that my cycle inventory is how much I order divided by 2. And my safety stock inventory is my reorder point minus my lead time during demand. We just talked about this part, the Q divided by 2, a couple slides ago. And we talked about this part very early in the lecture, right, where we said if I ordered 24,000 units and we used 20,000, we were expecting to use 20,000 of them, that would mean that my safety stock was 4,000, right? Okay. No, I'm sorry. If my reorder point were 24,000 units and we were expecting to use 20,000 of them, that would mean that my safety stock was 4,000 units. Okay. So that being said, I can get to my average inventory because I know that I order in quantities of 28,000 divided by 2 gives me 14,000 in cycle inventory plus my reorder point minus my lead time during demand. So that's the my reorder point is 24,000 and my lead time during demand is 20,000. Okay? And so then that gets us to our average inventory is 18,000. One formula that we didn't talk about, which is remember our inventory equals throughput times flow time. We can use that formula to say on average, how long do we have a unit of inventory in-house? Okay? And so my flow time is equal to my average inventory of 18,000 units divided by my throughput of 2,000 units per day, which says that on average I hold a unit of inventory for 9 days, right? And so, again, that kind of information can be helpful. How long you're actually holding stuff on hand. And there's more than one way to get there, but that's one of the ways that we can get there. Here's a prettier drawing, right, of our normal distribution curve. And what that's trying to tell us is the green part is our cycle service level, and the red part is the probability of a stock out. And we can use that norms inventory is a function that's available that, again, gives us the norms inventory. Which one is that? So the norms inventory, we input the service level. So let's say norms inventory, we would say we want a 95% service level. So I would put in norms NORMS INV, and then parentheses 0.95, and it's going to return the z-score that's associated with that. Okay, and I don't think it's inventory, I think it's inverse. Norms INV. Okay, and then on the flip side of that, there's the norms DIST. NORMS DIST, and these are in your textbook. And you can enter the z-score, and it's going to give you the percentage of service level. Okay? So those are, again, how Excel is going to help us solve those. I'll post the slideshow too, so I've got notes on the slideshow about those Excel, and I think I've got another example of that on here too. But again, they're in your textbook. Yeah, here I've got actually the written example. So we often want to determine what our safety inventory and reorder point is required for a particular level of service. So if we have a given level of service, we can identify that z-score from the norms INV, NORMS INV. Okay? And with the norms INV, okay, when you do with the S, you only have to put in the service level, right? And so that's going to return the inverse of the standard normal cumulative distribution, has a mean of 0, a standard deviation of 1, which is the z-score. Then we can compute the safety inventory. So we have our z-score, and we can take it times the standard deviation of lead time during demand, and that's going to give us our safety inventory. And then the reorder point is our lead time, LTD, lead time during demand, plus our safety stock becomes our reorder point. Okay? This is our average demand during lead time. I don't know why I said that backwards. It's our average demand during lead time plus your safety stock. Okay? Or, without the S, I can put in norm INV, and I can put in those 3 pieces of information, and it's going to then return the final number. Okay? So with the S gives you the z-score. Without the S gives you, and then you have to input those 3 pieces of information, it's going to give you the actual number that you're looking for. Okay? So if we're looking for that reorder point, we can use that formula to get there. Okay, so play with Excel a little bit and see how those function. So example 7.4 from our textbook says that our safety stock is 4,000 units, and this kind of builds on our previous example. Our provided service level was 78.81%. What if we wanted to increase the provider service levels to 85%, 90%, 95%, and 95%? How do we determine how much safety inventory should be carried to provide these levels? Okay. Well, I opted to use the norms inventory to get the Z-score because I'm more familiar with taking safety stock and understanding that it's the Z-score times the standard deviation. That's the way that I've calculated safety stock for quite some time. This book is the first time I've ever seen the norm approach where you input all 3 of those. So I calculated the Z-score. So the norms end at 0.85 is 1.04. And I take that Z-score times the standard deviation of lead time during demand of 5,000 units. And that gives me 5,200 units. Okay. My reorder point is my demand during lead time plus my safety stock. So I have 20,000 units of demand during lead time, and I have 5,200 units of safety stock for a total of 25,200 units. Okay. And what you'll want to do is when you're kind of working through the problems is take a look at table 7.2 and 7.3 in your textbook. The table basically goes through and recalculates that for the different service levels. I don't really feel like I need to calculate that 3 different times for you. I think you all, tell me if I'm wrong, you all understand how to use a Z-score. Is that right? With the standard deviation? Okay. And so basically, you're going to plug in 0.90, you're going to get a different Z-score, you're going to recalculate here, and then you're going to recalculate here. Right? But what they're showing us in that table is that as the service level gets higher, it's not a linear relationship. Okay? You start to have to carry a lot more inventory the higher the service level you're trying to meet. Okay? And how we would look at that from a financial perspective is, as we added safety stock, we would identify that inventory carrying cost and talk about how much that actually costs us to hold that extra inventory. And then think about what does that mean to us in terms of more sales that we can meet. There's probably some point where trying to achieve a higher service level is more expensive than losing a sale because we don't have the inventory.
Now, in the goal, it talked about inventory. They're about their new accounting process that Lee or whoever's making them. They said it was not a liability. You could count it under assets as far as inventory, and that had their numbers off. Do you know what I'm talking about? That chapter. What is he saying there? And kind of to what we're talking about, kind of here with inventory being carrying cost.
Well, it's a little bit different. There's 2 ways that there's kind of different sides to how we talk about inventory. What we're talking about is recognizing that there is a cost when you hold inventory.
Like depreciation or whatever else you have on it.
Well, that and then just the fact that there's the cost of capital that you have invested in it, right? If your interest rate is high, then just having money invested in inventory is expensive for the organization. So that's the piece that we're talking about mainly here. But what they talk about in the goal is just from a standpoint, I think it's always interesting. Sometimes our accounting or incentives can drive us in the wrong direction. And that's what's happening in the goal. Because of the way that they account for inventory in their system, that they are actually getting penalized because they're not building units, they're selling out of their inventory. And so from their accounting approach, they're getting penalized because they're not getting credit for the fact that those units are selling. What happened is they probably got credit for them when they built them. Okay? And the problem with that is building them and not selling them isn't a win, right? But their accounting system wasn't set up to capture that. And so that's why they're having so much trouble with where they're at now. It's starting to show that instead of showing that they're selling more of what they have in inventory, it's showing that they're not building as much. Okay. And so they're getting this, they're getting that hit from the fact that they're using up some of that inventory. So. And I'm not sure that I explained that exactly right. It has to do with the way that they accounted for the inventory, that maybe they didn't trying to think that maybe they didn't. Yeah, I can't remember. I'd have to go back and read that particular section.
That was one of the questions, and even when I was reading the book, I was having trouble breaking it down to how I wanted to explain it on the discussion board. So I was just
Yeah, so we could probably go out and look and see how everybody else has explained it a bit closer. That's something I didn't read it. I think did I read it at the beginning of the semester? I can't remember. But that's always when I kind of have to go back and get my head around again. But what I would tell you about that whole incentive approach is, and I think I've talked about that before, is if you do the right thing, in the long run, it's going to pay off for you. Because the guy that had the job out here before I did, he was very focused on inventory turns. He wanted to have the best in the company, and so he was keeping inventory so low, they never could get through 2 days without running out of stock because he had inventory so low. And how he perceived that is he was doing his job because that's what he was getting measured on, right? And so my perception of that is if you're running people out of inventory, you're not doing your job.
Yeah.
Right? And while there is a cost associated with carrying inventory, there's a cost of the morale and all of that goes along with it. And so, again, figuring out, so I never got the big accolades that he did for keeping inventory low. But on the other hand, they had never, before I got there, they had never gone 30 days without having a delinquent order.
Right.
Probably within 3 months of when I was there, we went 30 days without any delinquent orders. So it's all in your point of view. And then it's a message that you send to people. So my scheduling team, they were used to running out of things, so it seemed like it was no big deal. And so transitioning from that culture of running out isn't a big deal to it's a big deal.
Yeah.
We are not going to run out. We're not going to go way overboard, but we're not going to run out.
No.
And so I can remember when they got it, we had gone 27 days without a delinquent, and the plant manager had said he would shave his head if we made it to 30. We had a piece of glass that got broke, that if we reordered it the normal route, we couldn't get it for 3 days, and so we would take a delinquent on it. And I'm like, I think we've got somebody here on light duty that can get in a truck and go pick up that piece of glass. And they were like, really? You want somebody to go pick up that piece of glass? I'm like, I really want this guy that we've got on light duty who can't do anything else. He can get in a pickup and he can drive over and get that, and we're not going to take a delinquent. You know. And so, but that's the message then that they get is that's important, right? So, and the message they were getting before is what's important is that we keep our inventory levels really low. Yeah. And then you got to find a balance. There's got to be a balance. Okay, so again, but what 7.3 in our text is showing us then, if you look at that graph, let me just, for those that are here, I'll hold it up, and for those that are at home, you want to open it up to page 163. But what happens is, here's our service level at the bottom, and as our service level gets high, it takes increasing amounts of inventory to meet that service level. And so, again, we have to decide how much is that really worth to us, okay? So what we're going to finish today with, we've got several slides that are on this, I never know if I'm going to say it right, this PALU gear. So it's an example, kind of a case study that the authors of our text use, okay? And so this PALU gear, their demand fluctuates from week to week, okay? So in fact, weekly demand at each store has a standard deviation of about 30 jackets. So they're selling these jackets. And assume that it's roughly normally distributed. And so from a previous chapter, I think in chapter 6, we talked about their average weekly demand was 59 jackets. Okay, the order lead time is 2 weeks. Fixed order costs are $2,200, and it costs $50 to hold one jacket. All right, I want you to tell me if I were going to calculate EOQ. Can you do that from memory yet? Can you tell me what the equation is for EOQ?
Square root of, I forgot what the abbreviations are. It's 2SR.
Yep, you were right. Okay, and R is our annual demand. Capital R is our annual demand. S is our setup cost, and H is our holding cost. So if I'm trying to figure my EOQ here, all right, in this formula for EOQ, I don't need the standard deviation yet, right? I'm probably going to use that someplace else. So I have standard deviation of demand of 30 units. Average weekly demand was 59 jackets. If I assume 52 weeks, Brady, what's 52 times 59?
It is 3,068.
So that's going to be our annual demand. What's my setup cost or / ordering cost?
2,200.
Right, so I'm going to take all of that is my numerator. That's a rough 0, and that's a 2. Just it looks more like a 1 there. Okay, and my holding costs. Okay, if you remember, we've talked about holding costs in terms of unit price times inventory carrying cost. And what they do here is they just give us the total dollar amount. And they say that unit price times inventory carrying cost is actually $50 per jacket per year. Okay? And so some of that is just practicing with problems to know that they can give it to you in terms of unit price and inventory carrying cost, or they can just give it to you in terms of total price per year for carrying costs. All right? And so if I finish that out, I think that comes to like 520. So that's what we would order each time. Okay? And so then the question is, we want to look and see if the retailer uses the ordering policy discussed before, what will the probability of running out of stock in a given cycle be? And what can the Payload retailer do if we want that to be smaller? And how can she possibly get that service level up to 95%? Okay, well, we're not going to answer all that on these slides. We're going to actually move forward and look at a couple of other slides to answer those questions. Okay. This slide they have in there, and I left it in just so we can talk about an inventory profile. And basically what they're saying is an inventory profile is where we identify a reorder point, right? And so let's say here, if 140, 120, 40, 60, 80. So if this is my reorder point, right, every time my inventory hits that level, I'm going to reorder. And when it hits that level, I'm going to order in quantities of 520, which is our EOQ that we just calculated. Okay? And so then it's going to look something like I'm going to order, and, in a perfect world, it's probably going to come in somewhere around here, and it's going to shoot up 520 units, and then it's going to come back down, right? So that's how our sawtooth diagram would look. But that's what you're talking about when you talk about an inventory profile. You're just looking at what does it do over time, okay? And so we would want to say, on average, what's the stock level when the replenishment arrives? And on average, what's that inventory profile look like? And what's the probability that we're going to run out of stock? And how do we get that stock probability down to 5%? That's almost just a reverse of the questions that we looked at here. How do we get the service level up to 95% versus how do we get the stock outs less than 5%? That's the same question. Do you all see that? Okay. All right. We raise the reorder point until we reach an appropriate service level. To do the numbers, because our reorder point has to have our safety stock and our average demand during lead time in it, right? And so basically when it says we raise that reorder point, what we're saying is we raise our safety stock because we're not changing our average demand during lead time, okay? And so we use that standard deviation of demand during lead time, and we can use our Excel sheet such that the customer service level is equal to the normal distribution of Z, or Z is equal to that norm's inventory number, right? So we have a couple of different approaches. I think this slide is out of place, but I'm going to go ahead and talk about it for a quick second, okay? When we think about our standard deviation of lead time demand, we have all these different, if we have demand at different locations, okay, I'm going to make this as simple as I can, and then we'll hit it next week or 2 weeks from now. Our demand over lead time has a distribution, or excuse me, we can take that standard deviation of our demand times the square root of our lead time, and that's going to give us that variability for what happens over lead time. Okay? So I don't think I said that very clearly, so let me talk about it in a different way. If sometimes it takes 5 days for something to arrive, sometimes it takes 6 days for something to arrive, sometimes it takes 4 days for something to arrive, I've got this variability, right? I'm explaining that wrong. If my demand fluctuates, sometimes I have 5,000 units, sometimes I have 4,000, sometimes I have 6,000. I have a standard deviation of that throughput, of that demand, right? So that standard deviation of my demand, if I take it times the square root of my lead time, that's going to give me the variability measure that we can use, okay? We also have this standard deviation of demand where if I have multiple warehouses, and this goes to kind of what we talked about a little bit in Chapter 8. So if I have multiple warehouses and they all are dealing with a particular customer service segment, right, we have then segregated our variability. So I've said that the northeastern region is going to be served by New York. Right? I've said that the western region is going to be served by Los Angeles, and I said that the Midwest is going to be served by Chicago, right? I'm segregating my demand, okay? And when I segregate that demand, I have segregated the variability of that demand as well. And when I segregate the variability of that demand, it requires individual safety stocks at each location to deal with that variability, okay? When I pool all of that, let's say that I went from all 4 of those distribution centers to one large distribution center, okay, then I'm actually going to see a reduction in the amount of safety stock I need. Because where I used to have a high maybe in the northeastern region on one day and a low in the western region, now those two are going to balance each other out. So my variability is not going to be as high when I pool my distribution centers together. That's really what this slide is trying to get to. Okay? I think it's in a weird spot. I'm not sure why we use it there. I guess because we need it to determine the standard deviation of lead time during demand. Okay? So Payload Gear, when we say we want to determine the safety stock for 95%, okay, our throughput is 59 jackets per week. Our holding costs were $50 per jacket per year. Our ordering costs were $2,200. Our standard deviation of throughput was 30 jackets per week, and our lead time is 2 weeks. So, what should safety stock be to ensure a desired cycle service level of 95%? Okay, the answer, we need to require the number of standard deviations to meet the 95%. That's 1.65. We can go to any table to get that. Some of us will have that memorized because 95% is such a standard one used. Or we can go to Excel and plug it into a formula. Okay? If we need to determine our standard deviation of lead time during demand, right, that's the standard deviation of demand, our 30 units per week, times the square root of our lead time, which is 2 weeks, gives us 42 units. Okay? So that's our standard deviation of lead time during demand. And so our safety stock then is our z-score times our standard deviation of lead time during demand. 1.65 times 42 tells us that we need 70 units in safety stock. Okay? If we're trying to evaluate that information, we've said that our optimal order quantity is 520 units. You should be able to figure out how many times per year you're going to order. And I used the simple example. I've probably used it before and I'll use it again. If I said your annual demand was 12,000 units and you ordered 1,000 units each time, how many times a year do you order? 12. So all you've done is taken your annual demand and divide it by the quantity that you're going to order. So when you need to determine how many orders per year, you're going to take, we did 59 per week times 520 got us to 3,000 and some.
3,068.
Yeah. And so then we're going to divide that by our 520, and that's going to tell us that we're going to order 5.9 times per year. Because our order quantity is 520. Are you all following that? That might be one you might want to just make a quick note of. That when you're talking about orders per year, you're taking your annual demand and you're dividing it by the amount that you order each time. Because I don't think we have a formula on our slides that says that.
Can you say that again?
Yep. When you're talking about determining how many times per year you order, take your annual demand and divide it by the quantity that you order each time. And use that. If my annual demand, capital R, is 12,000 and Q is 1,000, then I order 12 times. That's always just a very simple example to kind of try to keep in your head. Okay? If I talk about my annual ordering cost per store, right, it's $2,200 each time I order, and each store is going to order 5.9 times. So that means that it costs them $12,980 to order. Their inventory holding costs are going to be their average inventory, 520 divided by 2, right, because that's how much they order as a quantity of 520, times $50 per jacket, right? Do you remember that holding cost? So their holding cost is going to be $13,000. And this is all for cycle stock, right? And so that makes sense because if you remember at EOQ, our holding costs and our carrying costs are supposed to be equal. Well, they're within $20 of each other. In the grand scheme of life, that's equal. That's a rounding error. Okay, our safety stock, basically then in terms of cost, is we calculated that we needed to have 70 units per store. Okay, and our holding cost then is 70 units per store because we have that all the time, times $50 per jacket is $3,500. So our total cost for the 5 stores are, we have to take 5 times the ordering cost per store of $12,980 plus the holding cost of $13,000 plus the safety stock at $3,500. So that's going to be 5 times the $29,480, which says that our cost there is $147,400 a year. Okay? So those slides are going to be posted. You know, don't be afraid to print them off and kind of noodle through those as you're looking at your problems and that kind of a thing. That is the extent of what I want to cover tonight because I think you have plenty to do with your projects and with kind of doing the couple of, I think, again, pretty easy homework assignments associated with Chapter 6 and Chapter 7. And then turn around and once you finish Chapter 6 and Chapter 7 homework, go ahead and start in on the exam.
In the Chapter 6 and Chapter 7 homework's due the first and so's the exam?
Yeah.
So just okay.
Yeah, because my thought is, if you want to wait until the last night to do them because you're working on your project, see, I'm thinking positive. You're working on other things, right?
Yes, I am definitely working on other things for sure.
Definitely.
So I don't want to dictate to you when you're going to get them, but I want to get them out there because I do have one student that I know wants to get to them and get them done. And
I would prefer to be able to work on some of them this week and stagger it because trying to do it, if you had them all due next week,
right,
it'd be
that. And then the other part is, you're probably not going to be the one that can work on your project all the time. You're not going to be, and so you're going to have times, and I don't know who's going to be doing what when, and so we'll just leave it with that flexibility. Again, I want to encourage you, come see me, or if you're an online student, call me if you're having trouble with those, okay? And because, again, we treat it more like a little bit more specific homework assignment. One of the things, are you feeling, did you get, I know what I was going to do. I was just going to look over again discard those.
You were supposed to get one wisdom tooth removed today, but then you ended up getting 3 teeth pulled out at the same in the back because they were so bad.
Who was that?
My boyfriend.
Oh gosh,
I felt
that's not good.
so bad for him because we were all only him, his mom, and myself. We're only expecting him to get one pulled out because it was his wisdom tooth in the back was just.
Every time I go to the dentist, I fear that they're going to tell me we're going to have to pull your wisdom teeth. But so far, I haven't gotten wise. So
Have you had any pain yet?
No, and that's what he said. Hell,
I would wait until you get pain.
Every time he asks me, I'd be like, "Have you feeling any pain?" Nope.
When I felt pain, and I'm like, "Mom, I'm getting all of them out. And I literally got all of them out within like the next month.
That's rough.
It was a rough couple days.
Yeah.
But
then it's over.
It's over, and you don't have to deal with it anymore the rest of your life.
My son, my oldest son, who's 6 foot something and a couple 100 pounds and then some.
These need to be second.
He had his wisdom teeth pulled, and of course they put him under for it. And then when they were done, they kind of set him in this little waiting room, and they're like, you just need to stay calm. He was like, I'm ready to go. He's like so ready to stand up, but he's just going to go, you know.
It's always the best time to get.
Yeah, so it's not like.
Yeah. And he made me promise beforehand that I would not record him, because right before he had him done, a friend of ours, her daughter had him done, and she recorded her, and she was so silly. She
I
puts it
told
out.
my mom not to, and she still did.
Oh yeah, no, I had ACL surgery, and my mom recorded me when I come to back in the wherever I was at.
I know. We can
I
be
asked the
mean
nurse
sometimes.
like 4 times how she was doing. Well, how are you? And she'd tell me, and then we'd say something, and I'd ask her, well, how are you? And she'd tell me.
All right, I wanted to go back to exercise 8.1 just as a quick reminder, because you're going to have problems like that on the questions like that on the exam, and so it didn't seem to me like maybe everybody was kind of tuning in to.
Those are my least favorite chapters.
So if we talk about, so a call center has 12 telephone lines coming into a customer service department, which is staffed by 5 customer service reps. On average, 2 potential customers call every minute. Each customer service rep requires, on average, 2 minutes to serve a caller. After great deliberation, management decided to add another line, increasing the lines to 13. As a result, the call center can expect the following. The proportion of potential customers getting a busy signal will increase, decrease, or be unchanged. We added a line.
So they should.
Increase?
No, decrease.
No,
Decrease, because there's another line for them to be put on hold to. So on average, that will decrease.
Okay.
Average flow time experienced by a customer will increase, decrease, or be unchanged. So think about, yes.
Yeah.
Why is it going to increase?
So it's in their line so they get through quicker because there's more people available. That's kind of how I want to say that, but now that you look at my
Flow time, okay, so it depends on, I guess we need to be more specific, because I would say decrease would go through faster, and it's going to increase, because there's 13 lines and we haven't increased the number of servers. So they're going to still process at the same rate, but these people are going to be on hold a little longer.
Okay.
Less people are going to get the busy signal.
Which means they won't leave and you get the...
But more people will be on hold, and so therefore we haven't changed the number of servers. So if you have more people on hold without changing the number of servers, they're going to wait longer. Okay? Average utilization of the customer service reps will increase, decrease, or be unchanged. So you had 5 customer service reps before, and you had 12 telephone lines. Now you have 5 customer service reps, and you have 13 telephone lines.
I'm assuming it's an increase.
It is.
I was just hesitant to answer since I got the last one wrong.
Yeah, it is an increase, because what happens is now you've got that extra person out there on hold, so we're going to deal with one more person, and we've not changed the number that we actually have in terms of servers. Okay? All right, let's look at the 8.2 as well. I think kind of once you get your head around it, it's not hard, but it doesn't always make intuitive sense the first few times through. Okay, 8.2. A mail order company has one department for taking customer orders and another for handling complaints. This is where we're talking about we have unpooled variability right now. We have one department here and one department here. Currently, each department has separate telephone numbers. Each had 7 telephone lines served by 2 customer service reps. Calls come into each department at an average rate of 1 per minute. Each rep takes on average 1.5 minutes to serve a customer. Management has proposed merging the 2 departments and cross-training all workers. So now we're going from 2 unpooled to pooling. So we know that our variability is going to go down because we're able to manage that. We balance out a little bit better. Okay. So the projected new department would have 14 lines served by 4 sales reps. As a process manager, we think the proportion of callers getting a busy signal will increase, decrease, or be unchanged.
I think it would be unchanged.
Okay. Okay, what do you think?
Increase.
Okay. The proportion of callers getting a busy signal. Okay. So we went from 7. So I'm over here, and I call in, and they're busy, and these people aren't busy.
Okay.
So I'm trying to call in, and I can't get in over here, but there are people over here that aren't busy. Mm-hmm. So when we say, now we're going to pool that, then the people who get A busy signal is going to be less because we're pooling that variability and it's going to balance itself out. Okay. Average flow time experienced by a customer will increase, decrease, or remain unchanged. Okay, and we're going to say decrease. The average flow time experienced by callers decreases. And I'm trying to think. Because again, you're taking that, you're averaging out that variability, right? Okay. That last one is not as clear to me as the other 5 that we just answered were, but again, they're going to be some questions like that for the beginning of chapter 8. So kind of make sure that you review those and get comfortable. Again, open book, open note. So, and I decided, like I said, originally it was only going to be chapter 6 and 8, but I decided to include 7 because what I found on the last test is there almost wasn't enough points. If you did bad on the one, then you were just pretty well done, right? And so on this one, I wanted to go ahead and add in a few more opportunities for points. So, all right, any questions? Okay. I need to hear from or have something submitted from this group up front. You need to tell me when that's going to happen.
Okay.
And we need to meet
for what you sent back to us.
Yep.
Okay.
And we need to meet, if not earlier than, we need to meet next Monday. Okay. I'd really like to see you guys submit something and then have us meet on Monday to review
I
that.
texted Lauren when you told me that, and I said, hey, she said she's replied to us, and she said, okay, I'll check, and then she emailed me back, and she forwarded us the email, and you said, looks good. The only thing that I see, the inventory unit of measure should be customers in the table. Yeah. So if that's the only problem, then all I got to do is change it to customers, and that's...
But it needs to go into the Word document. And she doesn't have it, and she doesn't... I pointed to Amber because she's been doing it, but when she sent it to me, it wasn't in the Word document.
Okay.
I asked her.
That sounds good.
Okay. So you guys need to get that
Then we need to send chapter 5 to Brianna.
Yes, but you need to...
Okay.
We need to make sure we're clear with her on what parts then.
Okay. Sounds good. Perfect.
Okay.
Love it.
Me too.
Walk back in the car and it's freezing cold outside. Somebody's gonna bug me because it's dark.
And then the only thing I have from you is you.
Luckily, I feel like I will probably not be the one to fall victim to mugging. There has to be easier people on campus.
That's your strategy.
Luckily, I'm big enough that I'm like, okay, maybe they won't choose me.
Amber, how's that making you feel?
I walk outside and it's like, choose her, not me.
Yeah. Good night, guys.
Okay, I got you.
How are you guys doing?
Read it right because
We're doing pretty good.
I just didn't know if it was the right word or not. I got a couple questions for you.
Okay, good. Do you want me to keep recording or stop recording?
It doesn't matter.
I'm going to go ahead and stop these because I think what we're going to do, we're going to be